Hey folks, Quilly18 here, and welcome to another episode of our Unity 2D physics game tutorial, where we make something that might be a pretty fun game to play on mobile devices or even computers. We're going to be stacking some boxes. So right now, we have the thing in a current state where when we click on the box, it attaches itself to our mouse, and, well, that's pretty much it. We're actually violating the laws of physics in a sense, because every frame, the box is teleporting to wherever our mouse is, which means we can do this weird sort of stuff where the box will pop into another object, which is really not appropriate. Also, to me, I don't like how fast it's moving. It's feeling like, I don't know, I'm dragging an icon on a desktop or something like that. It doesn't feel quite as physicsy as it could be. So we're going to make a quick little adjustment to make things feel a lot better. We're going to go into our mouse manager script. Just got to wait for MonoDevelop to load up. Anytime. There we go. Embiggen the text so you guys can read. And so right now, every frame we are updating the position of the object directly. And that's not really a physicsy way of doing things. Instead, we can move the object by simply giving it a velocity. Instead of teleporting the object to our mouse, we'll just shove the object kind of towards our mouse. And you'll see it's going to feel a lot better. So let's go ahead and figure out how we're going to do that. What we need to do is figure out what direction should the object move to move towards our mouse. Well, that's pretty easy to get. We'll get a vector 2 because we're working in 2D space. We'll call it direction. And so it needs to move. What we have to do is set its target, which is the mouse position 2D, minus its current position, which is the grabbed object dot position. This will give us the direction towards our mouse object. What if we take this direction and simply set it as the object's velocity? We're going to tell the physics system, set the velocity of the object to this direction. Just like we already have a script that set its initial velocity. Well, what if we do that? Well, let's give it a try. We're going to hit play. I'll click on the object, and then I'll move my mouse. And you can see it's now moving towards my mouse. Not particularly quickly. Although, have you noticed it moves faster the further away from my mouse it is, and then it gets close and close and close. Well, that makes sense because this dir is the direction. Well, it's not just the direction. It's actually the distance is really what this is between one and the other. So the further away we are, the bigger this vector is, so the bigger the velocity. Clear as mud? You could set it to a fixed amount. We could do something like dir is equal to dir.normalize, which forces it to be a vector of length 1, times some sort of speed, like maybe 10. That will give it a fixed speed of 10. This will lead to one probably weird behavior. Yeah, see? Sort of twitches around. No matter how far away the mouse is, it moves at the same speed as it chases the mouse around. And then when it gets there, it sort of jiggles back and forth because it keeps overshooting. It passes it too far one side, then passes it too far the other side, back and forth, back and forth. You could mitigate that through a few different ways, but I really don't like the fixed speed behavior. I really think it feels better when it moves at different speeds depending on its distance from the mouse. We will multiply the direction by some sort of speed. Actually, we'll go ahead and set float drag speed equals, I think 10 might be okay. So we'll multiply our direction vector by the speed and then apply that to our actual velocity. Then if we hit play, there we go. So it moves faster the further away we are, but as it gets close, it sort of slows down. You know, that's too fast. I don't like that. I think a little bit more latency there would actually feel better. Let's try a speed of 4. There we go. Not very quick. We might end up wanting something a little bit faster, but I like it, and I like how it slowly, approaches our mouse. Now, what's really interesting here, what happens if we let go? Well, we know what happens if we let go. We let go, well, nothing happens. Why is that? Well, if we let go while the mouse is just standing still, the last time it updated its velocity, the distance between the mouse and the object is basically 0, which means this velocity is basically 0. So, when we let go, when it's basically not moving, it will not be moving. What if we let go while we're dragging? Let's try it. Let go while we're dragging, and it'll just keep going. Because it's last set its velocity when the mouse was not very close, so it has some amount of velocity, and then it just keeps going in that direction. That's pretty cool. I think what would feel even better, what if, when we let go, when the mouse button goes up, before we let go of the object, what if we turn its gravity scale back on? Let's give that a try. So I'm going to grab the object. I'm going to let go of the object. And now gravity affects it again. Oh, that feels pretty good. Let's give it a little bit of an upward thrust. Oh, can you dig it? I'm digging it. This feels pretty good. The other thing, I forgot to mention a little earlier, is notice now, because we're not teleporting it by adjusting its position, it nicely latches on and has physicsy connections and just starts to feel pretty darn good. Now, if I do click over here and then release my mouse, we actually get a little bit of an error. See that? Null reference exception. And that's because, I notice this as I was tweaking the code here, we are setting the gravity scale of this grabbed object to 1 when we let go of the mouse. We're not actually checking to see if we're currently dragging an object around. So let's go ahead and just make sure. When we let go of the mouse and the mouse is not null, sorry, the dragged object is not null, then we'll set its gravity to 1. And actually what we might want to do is we might want to set its gravity to 0 explicitly every time we re-grab it, because of course we can grab an object, let it go, grab it, let it go, grab it, let it go. So every time we grab it, we'll turn the gravity back off, and then back on, and then off, and then on. And I'm thinking this is pretty nice. I'm digging this. In fact, we can make it slightly more interesting by adding another object to the equation. Let's go ahead and do that right now. So I've got another graphic over here. It's of a triangle. So I take this bad boy and drop it into our world over here. I would like the triangle to be a bit bigger. Again, I could scale it, but what I'm instead going to do is set its pixels to units to say it only needs 50 pixels to be 1 unit big. There we go. I like the size of this triangle quite a bit more. And I want to make this triangle basically act like another box. We'll call it triangle, because why not? But I want it to be a physics-enabled object, like the box, not like the platform. I want it to be something that moves around. So it means it needs 2 things. It needs a rigid body, obviously. Right? It needs a rigid body, so it's affected by physical forces like gravity. And what else does it need? Well, it needs a collider. So what collider might it want? Well, it's not box-shaped. It's not circle-shaped. It's not a one-way edge collider like you would use in a certain platformer type stuff. So clearly we have to use a polygon collider. Now, Unity is pretty smart. By default, when we set a polygon collider, it will create a polygon that more or less matches the shape of our object. So if we zoom in, and this will be a little bit hard to see on YouTube, I realize that. And it might become more obvious if I switch to the grab icon over here instead of the move icon. There's a bit of a green edge around. This is where the collider is. And it tried to create a collider that was reasonably shaped for this object. If we go ahead and pull open the collider info, we can see it's got 5 vertices. And if I hold down shift, I can actually see exactly where those edges are. There's one here, one at the bottom, one here, and one here. So it tried to make something that was a little bit of a thick triangle, and that's not bad. Now I may want to adjust that. I can do it pretty easily. I can click on one of these vertices while holding shift, and this is much easier if you're in this mode, because if you're in move mode or rotate mode or scale mode, it's very easy to accidentally move or rotate or scale the entire object. But if you are in this, there's no tooltip for this. It's weird. This grab mode, which the shortcut key for that is Q. All these is QWER to cycle between these. If you do that, you can't do anything. All you can do is select shapes. Actually, you can't even do that. All you can do is drag the screen around. So that way, if you're holding down shift, you can still interact with this object, but then you don't have to worry about accidentally moving something. So if you hold shift, you can drag these things around. If you hold shift in an empty spot, you can create new points like that. I'm just going to undo. If you hold control, you can actually delete one of these points. I think the shape is okay. I'm going to go ahead and, because this fuzzy edge over here, it tried to include that as part of the object, and I think that won't look quite right. Actually, we can go ahead and test it. Let's go back into move mode. Let me go and move this here, take this box, move it here. I'm going to take the initial velocity script off the box, and I'm going to tell it should be affected by gravity to start off with. So if we hit play, there we go. Let me grab that box though. You can see there's it doesn't quite look like it touches the triangle. A little bit too much of a space. So let's go and select our triangle, go into the Q mode, and then hold shift. And I'm just going to try to pull these a little closer, kind of like that. I could potentially even just delete these 2 control points entirely and get an actual triangle-shaped controller, collider. Whether or not that would be better or worse, kind of sort of depends on what you're trying to do and what your graphic is. Notice if you don't like these sort of blurry shapes, the other thing you can do, if we go to our actual triangle object, the filter mode by default is bilinear. If you switch to point, it won't blend the pixels. Bilinear or trilinear filter modes are very, very important for most times when you use a texture in 3D. But in a 2D kind of project like that, sometimes you actually just want the boxy pixels. So you can decide what you want. I'll go ahead and keep going with the fuzzy edge. There's a bit of a weirdness around here, but I'm going to live with it. The other thing you might want to adjust is whether you're using compressed graphics or not. The 16-bit will usually result in something a little bit oddly colored like that. But the true color will be the proper colors. And the difference between true color and compressed is the compressed will take up less space. Sometimes the compressed might look a little funny with these sprites. So you can try these different settings if you want. I'll go ahead and leave the bilinear. It looks pretty good on my actual game screen there, so I'm not going to complain too much about it. And now that I've adjusted the collider, does that feel a little bit better? Whoops. Let's go and grab this guy. Yeah, see, it feels like they're pretty much touching. Actually, I really like this particular phase of the project here because you're really getting a sense of physicality. So the platform doesn't move, but the triangle can sort of be bumped around. We can actually do a kind of a thing like this and get things just balancing on the edge. Ta-da! Can sort of push things around a little bit. I like that. If you want things to be more or less slippy or slidey, you can change the physics materials that are applied to objects. I'm going to not look at that in this particular tutorial, but it's something that you can look up, and then you can make things more or less sort of sticky and grippy or whatever. But the default settings tend to feel pretty good. Also, as a bonus, all this dragging behavior we have in this box, we can do exactly the same thing with the triangle. Because our mouse code, all it checks to see, did we click anything? And does that thing have a collider and a rigid body? Which it does. If we kind of bump against the edge, we can give it a nice little spin there. Doesn't that look great? Go ahead and just drop it down. Now, the one thing I will point out, it becomes quite obvious. As I'm dragging things along, you'll notice that the triangle is centering here in sort of the middle of the long side, the middle of the, I guess, the hypotenuse, which maybe doesn't feel quite right. In the box, it's like, yeah, it's great, right in the middle of the box. But for the triangle, wouldn't it feel better if it was right in the center of mass? Also, with the triangle, it becomes really obvious. What if I want to pick this edge up right over here? That's not what happens. It's the middle of the triangle, or the middle of the sort of, how do I make it more obvious again? There we go. And do that. And if let me pause and just get the triangle reoriented again. It becomes really obvious here that it's the center of this sort of bounding box that is what is being used for our position. It's actually this anchor point right over here. That's what's getting centered onto the mouse. Is that what we want? Ultimately, probably not. We're going to look, I think the next episode is when we'll look at adjusting that. For now, what we're going to do is look into adding just a bit more of a visual component here, because right now these boxes are sort of like ghostly following the mouse. Is that what we want? I think I would like a little bit of a visual representation of the connection between the object and the mouse. Wouldn't you? I think that might be nice. So what we're going to do is we're going to try to draw a line from the object to our mouse pointer to show that sort of physical connection. I think that kind of feedback is going to be really, really helpful. So it's very easy to draw lines. There's actually a few different ways of doing it. You could create your own meshes and stretch out sprites or do all kinds of nonsense. What we're going to do, well, that's not nonsense. Those are really valid ways of doing it. And depending on your project, may be the way you want to do it. We are simply going to use a line renderer. So I'm going to create a new empty object in my project, and I'm going to call it something like the drag line. Some line that shows up when we're dragging. I'm going to center the object, which is always, I don't know, it seems like a pretty good idea to have our object centered by default. I'm going to add a component on here called the line renderer. So line renderer is kind of an interesting object. It will draw a line. Now, you might say, well, where's the line right now? If we go, there's a few different things we can adjust. There's a material box, there's a position box, and a parameters box. The position one is particularly important. Right now, we say that the line has 2 segments, has a size of 2. So it just has a start and end point. We could have a line with like 5 segments if you want to draw various types of shapes. For us, we just want a straight line from point A to point B. So it starts at 0, 0, 0 and ends at 0, 0, 1. Well, we have to remember, right now in our 2D view, the z-axis is straight into the screen. So this is a line that goes straight into the screen, which explains why we can't see it from this point of view. If I pop out of the 2D mode in my editor, and then double tap on the drag line to center my view there and kind of rotate around, There's my line. Now, it's kind of ugly for two different reasons. One, it's this garish kind of pink. And the reason it's this pink is because there's no material assigned to it. When objects in Unity don't have any materials assigned to them, they're automatically this horrible pink to stand out and point out like, hey, you haven't textured me in any way whatsoever. The other thing is it's not so much a line as it is a square. And the reason for that is its width is set to 1. Its length is 1, goes from 0 to 1 in the z-axis, and its width is 1, which is of course why it would show up as a square. We can make it a little bit thinner, maybe 0.1. There we go. That works pretty well. If I do leave it, though, at a 1 for a moment, and maybe just make it longer, let's make it 5 units long. There we go. It'll actually poke through the thing. We can see something very interesting if we start to angle our view. It's this weird sort of flat thing, and as we go through the middle axis, it's why is it rotating around like that? What on earth is going on? This object is designed so that it always faces the camera, or rather your current viewpoint. So if I go here, and I go to the top, no matter how I kind of rotate my camera, it's always oriented towards me. And if I rotate sort of in this fashion, it's facing towards me. As long as the line is thin enough, it actually looks perfectly reasonable. It almost behaves, I don't know, like how you might see a cylinder. It's only when you look at it directly edge on that it's a little bit odd, but that won't be an issue in a particular 2D thing, right? Because we're always going to be looking at it quite flat. So let's take this drag line. Let's reset its coordinates. Instead of going through the z-axis and go back into orthographic projection here, we're going to have it go along the x-axis, say from -2 to +2. There we go. And then definitely we want to change the width, maybe to 0.1. That's not bad. We could even go a little thinner. 0.05? 0.05? That's pretty good. You notice there's a start and end color, but this doesn't do anything until you have a material attached to it. We could talk about what material we want attached to it forever. For now, we're just going to take an easy route. We're going to go and create a new material. We'll call it drag line material. By default, this is a diffuse shader. Now, if we attach that, and it defaults to a color of white, if we attach that to our material, or to our drag line, which is right over here, we're going to get a black line. Now you're going to say, why do we get a black line? It's set to white here, and in a material, it's set to white there. Well, the reason is the diffuse shader cares about lighting, and there are no lights whatsoever in our scene. All of our sprites use a special sprite material or sprite shader that does not use any lighting whatsoever. It's always fully bright, but diffuse one needs some light. So we could either A, add light to the scene. I think that would be a bit silly. B, we could change our ambient light color to full white. I think, no, that might not fix anything. Right, it doesn't use the ambient stuff because of reasons. Well, no, it does actually in a render. Never mind. That would work. So we could put on the ambient lighting to maxed out. Interesting. I didn't realize the ambient light doesn't show up in our scene editor. Huh. But I think what we really want to do is we just want to tell this material that it's, I don't know, it lights itself. It's self-illuminating is fine. There's a few different things we could do. We could use the sprite shaders. We could use the unlit one. The problem with the unlit one is it requires a texture. It doesn't just use a color. On the other hand, if there's no texture, I wonder, does it use just the start and end color? No, it'll just be plain white, so we don't want to do that. So let's just set it to white. I'm going to go ahead and just take a very lazy route and use self-illuminating diffuse, and that lets me set a main color. Why is it green? It's not green here. Oh, it's not actually green. It's just from further away because of reasons. So we're going to set the material. I actually do want green. I like a nice bright green, I think, for this selection line, and I think that's going to be fine. And I'm going to go ahead and change the ambient color back to sort of that medium gray. Just try to reset everything. Anyway, we've got some sort of green line. Yeah, we could do a lot better with the material, but we're going to move on. Anyway, so we have this line, and I'm going to switch my editor view back to 2D mode. We have this line like here. You'll notice one thing that's interesting. We've changed the position of the line purely by tweaking the numbers here in this position array. If we change the position of the transform of the drag line, absolutely nothing happens. The line renderer does not care where the transform of the actual game object is positioned in the game world. It only cares about these numbers over here. We can change the start and end color. We can do all kinds of things. Oh, you can turn off the use world space. And if we do that, then it will actually care about the local position. So depending on what you're trying to do, that may or may not be a good thing. We're going to leave the world space on. We need to tweak these numbers no matter what anyway. The idea will be the element 0, I guess, our start, will be the position of our object, and the element 1, our endpoint of the line, will be the position of our mouse. So we're going to be tuning those values directly. So where are we going to do that? Probably in the mouse manager script, I would think. So the mouse manager will obviously need a reference to our line renderer. So we can do something like this: public line renderer drag line. And then if we go back into Unity on our scripts, it will require a line render. So if we drag a game object in here that has a line renderer component, it will complete that link. So now we can reference this drag line here in our code. So the question is, where in our code do we put it? I'm going to start off by putting it in the fixed update code with the caveat that it will be wrong when it's here. Okay, so we can make changes to our drag line. First thing we're going to do, well, all we have to do is set the positions, and there's a function for that. It's set position. We give it the index of a position, so say position 0, which is our start, and then we have to give it an actual position in the world. Now, this is a vector 3 that it expects, so we have to convert our 2D vector to a 3D vector. Now, I could sort of cheat and use the so we've got our grabbed object over here. Our grabbed object, I can go to the transform and the position, which is the 3D vector, a vector 3. We could use that, but I'm not going to because of reasons that will be obvious in a moment. I'm going to say a new vector 3. I'm going to set the x to the grabbed object.x and the y to the grabbed object.y, and the z, I'll set to 0 for now, but we're going to see exactly why we don't. Oh, it's not grabbed object. It's grabbed object.position.x and grabbed object.position.y. It's worth noting that this grabbed object is a rigid body 2D, is what this variable actually is, and this rigid body 2D.position is a vector 2 that belongs to the sort of physics engine. So we have to feed in the z. So that's the start position. The end position will be a new vector 3, but it's going to be based on the mouse coordinates. Now, again, I could actually just feed it in the mouse coordinate directly. In fact, we'll try this and we'll see what will happen. It will not be correct. Have you figured out why? Let's hit play. Let's start a drag. Okay, there's a lot of things that are weird going on here. Actually, much weirder than I expected. Oh, derp. So there's like a second level of wrongness. The input.mouse position, again, if we recall, is the number that goes from 0, 0 in the bottom left corner to, hundreds in the top right corner, which is not what we want. We want the world space version of the mouse. This will still be wrong because of reasons, but somewhat less wrong. Hit play, start a drag, and why does the image sort of spaz in and out? Well, if I let go of the drag, so now it's no longer updating this position. It's sort of frozen where it last was. And if I hop out of 2D mode, we can see that this line is sticking out towards the camera. Why is that? Well, our mouse position, the world coordinate here, the 3D position of our mouse, is on the same plane as the camera, the same position as the camera, which means it's a negative 10 on the Z, which is not what we want. We want the two Zs to match. So, okay, that's fine. So instead of using the mouse position directly, we'll do a new vector 3, and we'll feed it the X and Y coordinate. Here, we can go world position 3D.x, or we could use the 2D version.x. They're exactly the same. I suppose for sort of consistency, we'll use the 2D one. It really doesn't make a difference. And most importantly, we want to feed in 0 as the Z axis. So now, if we go in and hit play, it will be slightly better, but it's got one problem. Actually, it's got two problems left. First of all, when the line is sort of, well, through the object, we can't see it. Why is that? Well, it's because they're all at the Z position of 0. In fact, if our background was at the Z position of 0, we also wouldn't be able to see it. So what are we going to do for that? Well, we're going to give it a slightly negative Z position. We're going to put it like -1. We're going to put it right in front of the objects, or rather, I should say, closer to the camera than the objects are. So now, as we drag around, there we go. We still see the line, which is good. But you can see here, there's something weird going on. Is it obvious on YouTube? When I drag this line, the start point of the line no longer looks like it's in the middle of the object. It almost looks like it goes backwards. The reason is it's drawing the line. It's starting the line based on the position of where the object is right now. We're changing the velocity of the object, but this change in velocity doesn't get applied until fixed update finishes. So we're setting the position, the start position, where it is now, but as soon as fixed update is done running and it processes the velocity, the object has then moved. So we don't actually want to do this right here. Where do we want to do it? Well, we could do it in update because update runs a little bit more frequently, so it should update it a little bit faster. Yeah, that'd be fine. I think the more correct place to do this would be in something called late update. Late update is just like update, but it runs after everything else. It runs after the physics. It runs all these things. So for purely visual stuff like this line drawing, it would actually make brilliant sense for us to do that in late update. So I'm just going to move it into here. You'll notice it's going to complain about the positioning. So let's go ahead and copy this as well. And that will work. Of course, we're not going to want to do any of this unless grabbed object is not equal to null, right? We're only going to do this if grabbed object exists. So we're going to go ahead and wrap that in an if statement like so. And now let's give that a go. And it should look a lot better. There we go. So now really it looks like it's properly anchored in the middle of the object as far as I can tell. Looks pretty good. Everything here looks pretty fine. And it's kind of a neat effect. You know, it gives you that proper sense of what's going on. But I think at this point, well, two things. One, I don't like the fact the line sticks around after we release the object. Obviously, we don't want that. Let's make a quick adjustment. On our drag line, let's disable the line renderer by default. And then in our code, when we grab our object, so right here is where we grab our object, let's take our drag line and enable it. And then when we release the object, we're going to disable our drag line. So now the line will only be present when we're actually dragging our object around. There we are. But the thing that becomes much more obvious at this point is when you grab, say, the corner of this triangle, I really think it becomes even more obvious that it's not really grabbing where we click. Also, this triangle, it really shouldn't be keeping this orientation. If I'm truly grabbing it from this middle, shouldn't it be more, please allow me while I sort of try to tweak this, shouldn't it dangle a little bit more like this, except not rotating? It's tricky to do. Come on, there we go. Shouldn't it dangle a little bit more like that? Like, I hope you're trying to see what I'm doing with like the down arrow pointing like that. And yeah, that might feel good because you have to remember all we're doing, we're not actually holding it from this spot. What we're doing is applying a velocity to the thing as a whole. So sort of just hovering there with like anti-gravity stuff going on. What we really want to do is change things so that instead of setting a velocity directly, we want to tell it, hey, you should be dangling from this line, this visual line, you should be dangling from it. And for that, we're going to need springs. And that will be next episode. See you next time, folks. Bye-bye.